Hello and welcome back to Chem Help ASAP. So in my previous video, we did electron configuration focusing on just the s and the p orbitals. Now we are going to look at our larger atoms and we're going to introduce the d and the f orbitals. Before we jump into our d and f orbitals, I do want to review where our s and p orbitals are. So you'll remember from our previous video, the s orbitals are these first two columns here, and our p orbitals are in these 6 columns here. I also want to do a quick reminder of your period numbers here. Remember, those match up with your s and p orbitals. With that being said, let's go ahead and locate our d and f orbitals. So our d orbitals are right in the middle. These 10 columns are your d orbitals. Your f orbitals, obviously you know where these are because these are the last, are down here. There are 14 columns here. These are your f orbitals. Yes, I did exclude this column right here for a reason that I will get to when we talk about the F's. But let's clear the periodic table and let's start doing electron configurations. We will start with an electron configuration that we can already do. We'll start with calcium. I am going to use my noble gas shortcut for this. So calcium is going to be argon, 4th period, s orbitals, 1, 2. Calcium is the last element we can do without talking about the d orbitals. So obviously next we are going to do the electron configuration for scandium, atomic number 21. I have one more electron than calcium, and the question is, where is that electron? Well, you already know it's in the D block because we identified that. However, the rule for the d orbitals is you must count back 1 from whichever period you are in. So I am in the 4th period, therefore these are the 3 Ds. So this extra electron in scandium goes in the 3d orbital. And the reason for this is from the energy levels from our orbital energy diagram. So if I am filling my energy level diagram, I will fill the 4s, then I will fill the 3d orbital. It's all about the energy level of the orbital. But let's go back to our periodic table. So we did our electron configuration for scandium. Let's do another element in the D block. Let's do the electron configuration for ruthenium, atomic number 44. I'm going to use krypton. Come down here, I'm in my 5th period. So that's the 5s, 1, 2. Now I'm in the D's again because this is my 5th period. My D's go back 1. These are the 4 D's. And count across 1, 2, 3, 4, 5, 6. Let's do one more electron configuration just dealing with the D's. We will do the electron configuration for selenium right here. Atomic number 34. Noble gas that I'm going to use is argon. Here I'm in my 4th period, so I have 4s, 1, 2. Moving into my 3Ds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you pass by zinc, you're in the p orbitals again. And remember, the p orbitals do match up with whatever period you're in. So I'm now in the 4 p's, and to get to selenium, I have 1, 2, 3, 4 electrons in the 4p orbitals. Since we have these electron configurations up, let's talk briefly about valence electrons. I'm going to switch colors. If we go back and look at calcium and we want to know our valence electrons, again, we look for our largest quantum number. That's easy here because it's only 4, so I have 2 valence electrons in calcium. If I go to scandium, I added an electron, but notice where I added it. I added it in the 3D. Obviously, 3 is less than 4. 4 is still my largest number. Scandium also just has 2 valence electrons. This 3D electron is a core electron. Taking a look at ruthenium, 5 is my largest number. That's going to be my valence. I just have 2. When I take a look at selenium, again, my Ds are not my largest number because they're 3Ds. However, I do have 2 4s. I have the 4s and the 4p. Therefore, I have 2 plus 4. I have 6 valence electrons. Now, I am not dealing with any exceptions here. I am strictly following my rules for core and valence electrons. The truth is the d orbitals and the f orbitals get a little hairy in terms of valence electrons. However, I do not want to deal with exceptions right now. I just want to show you the rules we use. Let's clear the periodic table again, and let's work with our f orbitals now. The f orbitals are contained in 2 series. You can see they're actually labeled here. The lanthanide series and the actinide series. They're simply named after these elements right here, lanthanum and actinium. Now, again, depending on your periodic table, you may see lanthanum up here and actinium right here. The reason you see lanthanum and actinium up here in the D block is because they do actually belong in the D block. So let's do the electron configuration for lanthanum. So that will be xenon, come down here to the 6th period, 6s, 1, 2. Then I move to the Ds. Again, I count back 1. That's 5D, and there's simply 1 electron here. That is the electron configuration for lanthanum. It does belong in the D block. So let's add 1 more electron. Let's do cerium and see what happens. Our additional electron belongs in the f orbital. So we've already talked about how the d orbitals count back 1 from whatever period you're in. The f orbitals count back 2. So cerium belongs in the 6th period, so it is going to be in the 4f orbital. Of course, there's only 1 electron for cerium. That is the electron configuration for cerium, 4f1. So just like the d orbitals, if we are counting valence electrons, the f orbital electrons will not be valence electrons when we are strictly following our rules. However, again, like I said with the d orbitals, the f orbitals can get hairy, but I am not going to deal with exceptions in this video. Let's do some more electron configurations with our F block. Let's do atomic number 96, curium. Curium is in the actinide series. It is in the 7th period. So I'm going to be using radon as my noble gas. Then I will have 7s 1, 2. Again, remember that actinium is actually in the d orbitals. I'm going to count back 1. So that is 60. There is only 1 there. Now once I hit thorium, I am in my f orbitals. My f orbitals count back 2. So these are the 5 Fs, and I have 1, 2, 3, 4, 5, 6, 7 electrons in the 5f orbital. Now that we have dealt with all of the orbitals, let's do some electron configurations that I find tend to trip students up most often. Just as a reminder to ourselves, I am going to put lanthanum and actinium just right here so we can remember that those do belong in the D block. So let's tackle the electron configuration for lead, atomic number 82. That is in our 6th period. So I'll be using xenon as my noble gas. 6s, 1, 2. Remember, D's count back 1, so 5D. Lanthanum is just 1. Now I move to my F right here. Those count back 2, so this is 4F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now I move back to hafnium right here. So I'm back in my 5Ds. I'm just going to keep on counting across. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, once I get past mercury, notice I'm in the p block. It can be easy just to keep on counting across, but I have switched orbitals. These are my 6p orbitals, and for lead I have 1, 2 electrons there. This is a valid electron configuration, but you may see this more commonly written a little bit different. Notice I have 5D1 here and 5D9 here. Usually people will combine this and they will write the electron configuration for lead like this. It is perfectly valid to combine all of your D electrons. Now what I recommend is when you're just getting used to writing your electron configurations, make sure you count across just like I did for this first electron configuration. Because otherwise, what I see happening is students just skip across all the F electrons and keep on counting through the D electrons. So often this piece here is simply missing because they've kept going with the D's and on to the 6P's. This is also why many periodic tables will pull lanthanum and actinium out to just give you a visual reminder something else is going on here, i.e., don't forget your F electrons. Okay, since we have the electron configuration for lead already up here, let's go ahead and count up our valence electrons. Let's see, 6 is my largest number, so my valence are my 6s and my 6p. I have 2 plus 2, I have 4 valence electrons for lead. Now, if you also wanted to know the core electrons for lead, based on its atomic number, we have a total of 82 electrons. 4 of those are valence. Therefore, we have 78 core electrons. The last thing I want to point out with these electron configurations is just like you can combine the Ds, you can also reorder the other orbitals. So some people like to count down, so they might write kind of running out of space there. They might count down 6, 5, 4. Some people like to count up. They might reverse that and put the 4 Fs, then the 5 Ds, then the 6 S's and P's. The order really doesn't matter. As long as all the electrons are there, you are fine. The most common mistake that I see students make is they will forget their F electrons. So if you have a periodic table that you take to class, that maybe you take notes on, make sure you make a note of those F electrons, and just because they're at the bottom of the periodic table doesn't mean we can forget about them. Anyway, I hope you found this video helpful, and thanks so much for watching.